Hi, my name is Dr. Jay and I welcome you all to the second video on the GATE series for metallurgical engineering. In this video series, I will be talking about different concepts and methods associated with metallurgical engineering and material science. In this particular video, I am talking about second and third law of thermodynamics. The second law of thermodynamics is also called as law of increased entropy. It states that total entropy of an isolated system can never decrease over time, or any spontaneously occurring process will always increase the entropy of the universe. That is, delta S of the universe will always be greater than 0. Here S is the entropy, which is the measure of randomness, and delta S is a change in the entropy. In simple words, suppose we have a system like this and we are supplying Q1 amount of heat to the system. Now, not all the heat that we are supplying will be converted to the work done. So if we are supplying Q1 amount of heat to the system, it will do W amount of work and Q2 amount of heat will be released from the system, or it may be contained in the system. Not all the heat will be converted to work, and in the reverse scenario, if we are working on the system, not all the work which is done on the system will be converted to heat. So the efficiency of any system is not 100%. This is basically what is meant by second law of thermodynamics. There are different statements which says the same thing. For example, the Kelvin-Planck statement, it states that it is impossible for a heat engine to produce a net work in a complete cycle if it exchanges heat only with bodies at a single fixed temperature. And the Clausius statement, it states that it is impossible to construct a device operating in a cycle that can transfer heat from a colder body to warmer without consuming any work. Essentially, it says the same thing, that if we are supplying heat, the system will not convert all the heat into work done. And if we are working on the system, not all the work done will be converted to heat. And this is what we mean by second law of thermodynamics. Now, the third law of thermodynamics. It states that entropy of a system approaches a constant value as its temperature approaches 0 Kelvin, or entropy of a perfect crystal at a temperature of 0 Kelvin is equal to 0. So, initially, when we have a system at more than 0 Kelvin, there is a certain amount of randomness or disorder in a system, and because of that there may be some entropy. But if we reduce the temperature of the system to 0 Kelvin, now the system does not have any heat. So there is no heat in the system, and all the atoms and molecules have lowest energy possible, since we are not providing any heat, or the system is not able to achieve or get any heat from outside. And that is why the entropy of the system will be approaching a constant value, which is the minimum possible energy a system can have. And this is what we really mean by third law of thermodynamics. In the next video, I will be talking about unit cell and crystal systems. Thank you.